Hello, everybody. I'm so delighted to be here as a speaker, and welcome to my talk. My name is Yuanzhen. Maybe you can call me Xu. Yeah, Peter is my collaborator, but he can't arrive here because of his family stuffs. Okay, well, let's begin our talk. This is the agenda, you can see. So we can start with the abuse connection resource, the first one. Yeah, first of all, let's review some basic concepts about JDBC and gndi. As we know, JDBC is a crucial component of Java application when the client endpoint connecting the database. gndi is an application programming interface that provides naming and directory functionality to applications. Yeah, as you see, this slide illustrates how to leverage gndi to connect JDBC data source. The client tries to communicate with the gndi tree, as you see, to connect JDBC data source. And the client tries to communicate with the JDBC tree and establish the session in the connection pool. Finally, it connects the database with a specific JDBC driver. Next one. Yeah. Therefore, we analyze plenty of JDBC driver source codes. We expectedly find some juicy JDBC properties which can be utilized to create a gndi connection. Yeah. In this slide, we find a group of properties related to JDBC connection in Infomix JDBC driver. You know, it belongs to IBM. I'm sure you are well. It seems like a remote execution involved gndi injection. Okay, we try to construct an available POC, but it does not work. Just like this. Then we analyze the source code back and forth. The function in the highlight area, you can see the search method draws my attention. While debugging the code, I try to search LDAP code base, remote code base. Next one, we step into the method P underscore search. It deals with variable which input from search method in the highlight area, you can see. And then next one, we keep on stepping into the P underscore result intermediate method. As you see, it deals with the variables which input from P underscore search method. Yeah. Then I stepped into the C underscore result intermediate underscore NSS method. It handled with the variables which input from P underscore result intermediate method, as you see. So At last, we can say the C underscore lookup deal with the variables which input from the result intermediate SS method. So consequently, yeah, the invoking relationship simply looks like this. Yeah, the search method, you can say, invokes the P underscore search method, then the P underscore search method invokes the P result intermediate method, and then it invokes C underscore lookup method. Finally, the gndi lookup can be triggered, as you see. Yeah, this is a stack trace in green color. Oh, sorry. Yeah, according to the above analysis, we can construct the available POC and trigger the IC involving gndi injection successfully. I did not disclose the detail about the POC. Yeah. The next section, in this section, I want to talk about another attack scenario, arbitrary log file writing. Yeah. I have analyzed a lot of JDBC drivers. Yeah. Substantial JDBC drivers support writing the tree log into a file by JDBC connecting property. The file extensions of some JDBC driver log file can be customized like .jsp as a web shell. For example, the IBM JDBC driver, it has 3 properties for this trace log named trace file, trace level, and trace file append. With the trace file property, the user can specify the name of a file into which IBM data server driver for JDBC and SQLite write trace information. So we can easily write the malicious code in JSP for remote code execution, as you know. However, in a relative scenario, like leaving a web shell in the web logic server, it's not practical because of the illegal hex characters. Yeah, just like the below. In escape pattern, actually, it is a portion of a JSP tag. Well, I have to invade the restriction, as you know. Yeah, I find only the servlet version 2.3, earlier than 2.3, then the EL expression are disabled by default. Fortunately, the WebLogic Server 14 supports the servlet 4. Just like this, the official document has described. So I can use the EL expression to invade the URL decode exception. Just like this. Then I construct a complicated backdoor for store the login console, username and password, as you know, by EL expression. Just a backdoor web shell in WebLogic server. It's very, very long. When we go to the web shell URL, the EL expression has been executed. the login console username and password are stored. Just like this. This is my username and password. But how to inject a discoverable memory web shell into the WebLogic server? Well, by the way, I wanna say the memory web shell differs from the traditional web shell. It's a kind of fileless backdoors, as you know. And they only exist in memory instead of disk. Yeah, actually, the memory web shell has a diversity, like agent type, a servlet type, a filter type, and a listener type. In our scenario, we can construct a filter type web shell. The crucial process is how to inject the malicious class into the WebLogic server dynamically, as you know. Yeah, let's take a look at the ideal processes as follow. Just like this. Yeah. Firstly, we need to acquire the request object of WebLogic server by current thread. And secondly, we need to utilize the malicious class to implement new, as you know, filter register. Thirdly, we need to insert the bytecode of malicious class with BCEL. Incidentally, the BCL is short for the bytecode engineering library, and it is used to analyze and create and manipulate binary Java class file. Yeah, that write class named WebLogic mem file, just like this. It is used to acquire the request object of WebLogic server with current thread, and then I write another class here to convert Java class to BCEL code. Just like this, it's a BCEL transformer. Yeah, it's really, really long, as you see. When we go to the web shell URL again, the malicious code is executed as well. Now we can have a backdoor in memory successfully, and arbitrary command can be executed as follow. Just like this, The memory shell is here. We can execute any command. Okay, let's go. Section 3, in this section, I will talk about lexical, syntax, compatibility, just like this. Yeah, as you know, in MySQL database, a blob is a binary large object that can be held a variable amount of data. And a blob values are treated as binary strings, actually byte string. Yeah, MySQL JDBC driver uses like this, prepare statement, set blob method. So I review the code fragment of set blob method. The set blob method tackles parameter index and input stream, as you see in the slide here. Sorry? Yeah. As we know, when we create a JDBC connection in MySQL database, we can set a character set like UTF-8 or UTF-8MB4 and GBK. Unfortunately, GBK character set is vulnerable. Yeah. First of all, let's look at the two ASCIIs of single quote and a backslash. Yeah, the setup method of MySQL JDBC driver appends single quotes around the blob data, and it escapes the single quotes and a backslash. So after processing, the byte stream transferred like the illustration, as you see here. So we create a malicious image and insert into the table as blob data. Yeah, just like this. And then in my illustration, we can see I dropped the table successfully when I establish JDBC connection and insert a malicious image. Yeah. Okay, let's go. Section 4. Let's go and talk about another scenario. Unchecked initialization class. Yeah. Okay. When I review IBM JDBC driver code source, I find a particular property named plugin class name, just like that, which is not mentioned in official document. Then I step into the source code. There is a Java bin with getter, getter and setter methods. According to the code analysis, the user can input a Java class as the property value without any verification. Yeah. Yeah. However, I find only a no argument constructor in the Java class can be risky. I illustrate it with an ideal Java class, which leads the malicious class from the remote code base and triggers remote code execution. Just an ideal class, not in real-world scenario. So, just like this. Yeah. When we establish the JDBC connection, the ideal class will be initialized. Well, we need to find a no argument constructor in a practical Java class. So we keep on trying. At this time, I record the GNI. As you know, GNI is short for Java Native Interface. It's a standard programming interface for writing Java native methods and embedding the Java virtual machine into native application. Yeah, just like this. As you know, system.load library method to revoke the libraries from various platforms, yeah, like Mac OS, Windows, or Linux, whatever. So we can use some dynamic analysis technology like CodeQL or, in China, Tabby to find the satisfactory Java class. We finally get the class, this one. Yeah, Unix system. It contains a no argument constructor, which leads a library named JAS underscore Unix here. So we can hijack the Java library, JAS underscore Unix. Actually, in Windows platform, there is a class named NT system. Maybe you know. So this is a demonstration of gndi backdoor for command execution. I replaced the original library with this backdoor library. Just like this, I establish the JDI connection again, and the remote code execution has been triggered successfully. Yeah. Yeah, we also find the same problem existing in other JDBC driver. We find the parameter credential provider in our analysis of Google Cloud Spanner JDBC driver. Yeah, a deep dive into the source code, and we find a class can be essentially here with any check. Yeah, just make it so you can leave the hidden, backdoor visit for APT attack. Yeah. Next subject is about Apache Calcite AVT JDBC driver. Actually, we find it during a pen test. Sorry. Yeah. Actually, we find it during a pen test engagement for, data integration plan 4. We report, and it was assigned a CVE number. Okay. Firstly, we focus on the property HTTP client underscore implement. The class which implements HTTP class used to send HTTP requests from client to server, as you know. So we create a JDBC connection with an IDO class as follows. Sorry. Yeah, deep into the code, we can see the class instantiate, and there is no invocation of arbitrary constructor with URL argument due to unchecked superclass. Yeah, so we construct the ideal class to prove it. Yeah. As you see, the command has been executed. Yeah, we also need to find a practical gadget in real-world scenario, as you know. So at that time, we leverage dynamic analysis tools to look for, the particular gadgets. We scan the code base for unchecked class in property values. Actually, we write a custom fork of Gadget inspector to find suitable, exploitable constructors in common library. Yeah, and finally, I find that we find a lot of potential gadgets and verify them. Eventually, this one, the green one, I pick up it. Yeah, we can see the code fragment. It's one argument construct, and the argument is URL type. So we can make a sensitive information leakage in JDBC connecting exception with this gadget. In this case, I require the sensitive information of HTC password. Okay, let's go. Next section, I keep on talking about incorrect response disposal. Yeah. First one is about the Snowflake JDBC Driver. As you know, Snowflake, yeah, we begin researching bugs in the area about browser-based SSO integration with the JDBC drivers. The idea that the attacker can control the server and the client can control the server response and change client behavior. Yeah, it's similar to ROG MySQL Server research, as you know, done several years ago. Yeah. Let's review the code. Observe command injection to launch browser. Yeah, platform-specific commands. So like this, you can see runtime.exec execute. Yeah, actually, this type of feature will always have a risk of command injection. Yeah, and then we construct a fixed server as follows. This one, a fixed server. Yeah. Then we set up a browser-based SSO from external. For auth, JDC Driver requests the URL and pass JSON response. Yeah. Pass the value of the data.sso URL method JSON format property to, as you know, here, runtime.execute method as a second parameter. As you see, the first parameter is open on Mac OS and remote code execution on Mac OS too. Yeah, just like this. Yeah, and finally we make it. Yeah, just like this. We find it and report to Snowflake disclosure program. Program was great to work with, supportive of this talk. Yeah, thank you to the Snowflake team. Yeah, actually, not only JDBC was variable here, but also other language had similar vulnerabilities in this area. As you know, Node.js, .NET. Okay, this slide, let's go. Google Cloud spanned JDBC driver, forward SSIF, GCP allow delegated credential to AWS, expose a design flaw in GCP auth library. Yeah, in all language that we look at. Yeah. Design flaw can lead to forward SSIF by supplying a craft set, of credentials. The parameter encoded credentials allows users to set their own Google Cloud Platform credentials in base 64 encoded JSON through this on-document property. Yeah. Something else we need to know, GCP credential JSON is used for all auth to GCP. Yeah, JSON is deserialized by different implementations. We are tagging the from JSON method. It supports many external credentials, including AWS. The AWS implementation makes several HTTP requests based on the provided configuration. So we constructed the credentials response as a JSON format, just like this. Yeah, we go back to the source code. The retrieve resource tackles the credential source URL, just like that, the highlight area. So, the POC, just like this. Yeah. And then we acquire sensitive information of HTC Password. We report it to Google WeIP and get a $500 reward. Okay, the last one. The last case is a Teradata JDBC driver. As you know, Teradata JDBC driver has an interesting parameter, browser. Yeah, it leverages browser-based SSO, while Teradata server configuration, enabling OpenID, Connect, OIDC, yeah, and the JDBC URL parameter. The client OIDC handling requires the server to confirm that OIDC is configured, and this allows the JDBC driver to use the browser-based SSO code path. Yeah. On any Teradata server where OIDC is enabled, actually. So let's dive into the source code. Here we can see the method which can execute command. Yeah. Runtime, yeah, the runtime. So we create a fake Teradata server in Python, which tells the client OIDC has been configured on the server. This tricks the client into allowing the browser JDBC property. Yeah, does not even require a working Teradata server to achieve ICE on the, machine running the JDBC client, similar to the ROG MySQL server login file explored from, many years ago. And here, we construct the fake server with Python. It's like this. The process is like this. A JDBC client connects to the fake Teradata server. A fake server tells client OIDC is enabled. Yeah, JDBC client makes URL request to OIDC server. Is expecting JSON document with OpenID configuration format. JDBC client executes the command in browser property. Yeah, just like that. Okay. The OS command has been injected and triggered. Okay. I'd like to talk some more tricks which can bypass high version Java reflection restriction via Teradata JDBC driver. We can combine three attack interfaces, JDBC, gndi, and Java deserialization, just like this. Yeah, as we know, since JDK 17, the Java reflection is limited by default. However, JDBC connection can be leveraged to invade JDBC deserialization with reflection in JDK. Firstly, we take a look at the bin utils gadget in WhiteSOCR. We use the WhiteSOCR tool to generate coms bins utils payload. Java reflection has been restricted in Java 17. Here. So the class Teradata source provides a serializable data source implementation here. The gets and the sets in Java bin are utilized to set JDBC connection properties. So we slightly reform the com bin utils gadget with the Teradata JDBC Driver class. Just like this. That we use WhiteSOCR to generate again, the payload again. The Java reflection has been invaded successfully. Okay, the last section, we give you some suggestion for protection. If you expose JDBC configuration to users in your software or service, use an allow list for JDBC practice with a minimal viable set for business service needs. Use only vetted JDBC drivers and do not allow user upload, as you know. Pay special attention to configuration properties which affect file writes and network OS command. Just deny this by default. Sandbox user originate JDBC activity in dedicated VM or cloud function. Assume the environment will be compromised and minimized blast radius. Regularly. Just like this. Regularly review JDBC configurations and usage for malicious or unexpected configuration. JDBC driver should be a part of your component version life cycle strategy and keep them updated. And if you are developing a Java, JDBC driver, do not trust user provided properties, especially, when the properties are used to invoke network calls, OS commands, or code through reflection. Just beware of malicious server and consider their, use checksums or other verifiable data exchange mechanism. If you are forking existing JDBC driver, make sure you stay up to date with the upstream driver and ensure you are applying particularly security fixes. That's my opinion, my suggestions. Okay, that's all. This is my talk. Thanks for your coming. To attend my talk. Thanks a lot.